Okay, Advent of Code day 5. Technically today is day 7, but I fell a couple days behind due to some real life things going on. And today's Saturday, so it seems like a great day to catch up. So that's what we're going to do. Let's get started. Okay, one of the very first things I've learned from doing Advent of Code this year is that the first challenge they give you is sifting through the instructions to figure out what is actually needed to be done. So here's some filler, here's some filler. The elf must recognize you because they're wasting no time explaining that the new sleigh launch safety manual updates won't print correctly. Okay. Failure to update the safety manuals would be dire indeed, so you offer your services. Okay, sounds clear. Protocols clearly indicate that there are new pages for the safety manuals that must be printed in a very specific order. The notation X bar Y means that if both page number X and page number Y are produced as part of an update, page number X must be printed at some point before page number Y. The elf has for you both the page ordering rules and the pages to produce in each update, your puzzle input, but you can't figure out whether they're in the correct order. So this is the input. This is interesting. The format changes. The first section specifies the page ordering rules, 1 per line. Okay, so that'd be this section. The first rule, 4753, means that if an update includes both page number 47 and page number 53, then page number 47 must be printed at some point before page number 53. Doesn't need to necessarily be immediately before 53. Other pages are allowed to be in between them. The second section specifies the page numbers of each update because the safety manuals are different. The pages needed in the update are different to the first update. 75, 47, 61, 53, 29 means that the update consists of the page number 75, 47, 61, 53, 29. Totally makes sense. To get the printers going as soon as possible, start by identifying which updates are in the right order. Okay, so we're really just checking we're getting a set of rules up here, and we're getting some updates to apply them to. And then there's some information here about how this is processed. Okay, so I think I understand this one. So I'm going to grab my input and jump into it. Oh, okay, hang on. There is an extra piece. So the elves also need to know the middle page number of each update being printed. Because you are currently only printing the correctly ordered updates, you will need to find the middle page number. Determine which updates are already in the correct order. What do you get if you add up the middle page number from those correctly ordered updates? Sheesh. Okay. Again, like these problems are so wordy. So let's go to our Advent folder. Let's create a folder for day 5. I'm going to create a new file called main.ts. I'm going to create a file called input.txt. Paste my input here. I have scrubbed all my inputs. I'm actually just going to do a .get ignore, and then we'll do I think that should cover it. We'll find out. Okay. I'm going to grab our main from day 4, paste it here. I'm going to gut a couple different things. So we don't need this isMatch function anymore. We don't need this. We don't need this. And we don't need this. Oh, that is correct. I need to update that. Okay. So we have part 1, part 2. We have our input text that we're getting. I think maybe the first thing we do, since this input is a little different. Sorry, my dog is eating some food. Since this input's a little different, maybe what we do is we start by writing a function that will get the rules and the updates destructured properly. So function get rules and updates. We're going to get an input string, and then we're going to get something like const ordering rules, updates, input, split. So we know that it's a full line break, so it's going to be 2 back-to-back new lines, I think. Hopefully there's no carriage returns or anything like that that we need to account for. So then we can map this. So we're going to get the element. We also, I think we're also going to want the index. So we come down here. Not sure why I did that. We want to split this on line breaks. And then we want to map. Hang on, this is way more complicated than I had planned. Okay, let's just do this for now. So we get our ordering rules and our updates. We can take our ordering rules, which is a string. We can split that on line break. And then we can map all of these. Take a look at our input text. So then we can map all of these to return e.split. And then we just want to split by the bar. And then we want to map those to numbers. Need to assign this. Changes, I guess. Need to give it another name. And we're going to do basically the same thing for our rules here. Or sorry, for our updates here. So we're going to split this on new lines. Then we're going to map. And then we're just going to return e.split. These are comma separated, I think. Let's check. Yeah, those are comma separated. Okay, cool. Okay, so we have our ordering rules and we have our updates, and those are being returned here. This is going to be, and then this one is going to be the same, number. Okay, cool. So with that in mind, let's update these so that this one is getting ordering rules changes, and we know that this is number, like that. And part 2 will get the same input, I would assume, so I'm just going to go ahead and update that as well. So now what we can do is we can say, give me rules and changes, get rules and updates, input, whoops, input, oh, sorry, contents, not input. And then we'll pass in rules and changes here, and then rules and changes here. Okay, sweet. Off to a good start. Now we actually need to define whether this is correct. So we have our rules, we have our updates. Why, hang on, one question, why are our updates? So we're essentially going to take this down to a single value. And that value will be a number, and it will be how many rules are correct. And then specifically, where if there are correct rules, we want to get the centermost page. Where there are correct rules, we want to get the centermost page in the set of changes, and then we want to add all those together. So to me, that sounds like we're going to do a reduce, and it sounds like we're going to reduce the number of changes, because we want to go through every change, and the rules could be used multiple times per change, so that makes sense. We basically want to iterate through the changes. So we do reduce, we get our ACC, we get our current value. If you've followed along at this point in our advent of code, I always use ACC and cur. This is the accumulator, this is the current value. Some people do like I don't know what they would put for ACC, to be honest with you. I always do ACC because it's the accumulated values, but I'm not sure what else people would put. Some people put like update or next or something here as well, but that's what cur is in my case. Okay, so we have that. We're going to return a value. We're going to do something with the accumulator. And then we need to set our default is going to be 0 because we want to work with numbers. So we are passing in a empty state number, which would be a 0 in this case. So we have our accumulator. We essentially want to check like correct. If correct is true, then we want to get ordering rules. No, we actually don't want the ordering rules. We want the changes. So if this is going to be correct, then we want to get the changes, and we want to get the center one. So we're going to need to floor this because there's a chance that it is an odd number. There's a chance that it's an odd number. So we do cur.length divided by 2. Otherwise, we're going to just add a 0 because we're not, we still need to do something here, but we're adding 0, which is essentially close to no op as you're going to get. So I think we're good there. I think we just need to figure out what this correct function looks like. So let's make this a function is change, let's go with, no, not current, correct, oh my God, C-O-R-R-E-C-T. So we're defining another function here. This is going to need like our ordering rules. And then this is going to need the current rule. Let's go with that. The plus operator cannot be applied to types number and number or numbers. Oh, this shouldn't be changes. It should be the current change. Okay, cool. All right, so we have this function that we need to define. So let's come here, add missing function declaration. Let's pull that up here. Okay, how do we define if a change is correct? So we have our rules. So let's do ordering rules. And we essentially want to check if, okay, hang on, let's think. So this is going to return a Boolean. So let's add some types. And we need to return, so we're going to do something with our ordering rules. We essentially want to check if some of these are not true. So if not some, we have like an A and B here for our rules. And then we basically just want to check if cur is a terrible name. This is going to be called change. Change includes A, change includes B. It needs to include both of them. And change.index of A is greater than, less than, yeah, I think it needs to be greater than because we're negating it here. So change.index of B. Okay. Sure, seems reasonable. It might be good to write a test. Thankfully, they have given us a massive test input to test with, and that's kind of the whole point. I think that might be it for part 1. Let's try it. Wrong project. Let's go into 5. Deno run main.ts allow undefined undefined. Okay, cool. Oh, I need to return the value here. Let's try that. Sure, let's give it a shot. Oh, we were right there. Submit. It's not right, your answer's too high. Okay, so first thing I'm gonna do is I'm just gonna console log R and console log C. I just wanna see what these look like and make sure that I am destructuring these properly. Okay, that looks good. Yep, that also looks good. Okay, cool. So we get our changes. We're reducing our changes. we take our accumulator, we add a value depending on if the change is correct. So if the change is correct, we're passing in our ordering and we're passing in the current change. If so, then we're looking at the change, we're calling math.floor, we're getting the length, dividing it by 2, so that's gonna round that for us, nice and easy. Otherwise we return a 0. Okay, that seems like what I would expect. So let's check and make sure that this is correct. So if the change is correct, we have our ordering rules, we have our change, our change includes A, our change includes B, and then our change index of A is greater than change index of B. And we're negating that, so I think we're good there. Let me flip these and just see what the other value is. I'm sorry. It's the same? Why is it the same? So, okay, we're checking if some of these cases are not true. So if it does not include A, here, let's flip this. I don't like that. If it does not include A, or it does not include B, or, okay, 0, so that breaks something too. How fun. Okay, looking through my code a little bit more, I think my issue is in this isChangeCorrect function right here. And our ordering rules, our change, we're returning a Boolean. We're returning not some, oh my goodness, we're not returning this value. That makes way more sense. Let's give this another shot. 4609. 4609. Okay. Hey, that's the first one. Cool. Continue to part 2. While the elves get to work printing the correctly ordered updates, you have a little time to fix the rest of them. For each incorrectly ordered update using the page ordering rules. So we're going to use those rules again to put the page numbers, use those to put those in the page numbers in the right order. Oh, okay. So we're going to change them. After taking only the incorrect ordered updates and ordering them correctly, then take their middle page numbers and add them together. Okay, cool. Puzzle input hasn't changed, still have the same. All right, so let's start on part 2. So part 2 is, I guess we're gonna essentially just modify the rule set. So, and we're gonna keep iterating over it while it's incorrect. So what we can do is while change is not correct, but I think we still need to iterate through the changes, right? Yeah, we do. Okay, so let's return changes, reduce, we get our accumulator, we get our current value, get over here, and then we want to return our ACC plus, actually this is basically gonna be the same thing, right? Plus is update correct, is change correct, then we're gonna pass in our ordering rules, and then we're gonna pass in our update. Sorry, then we're going to pass in our current value. We go here, we'll default to 0 in this case, if it's already correct. Otherwise, we're going to need to correct it. So we're going to call correct, correct change. And then we're going to pass in our ordering rules and then our change. And then the response from that is going to be the list of corrected numbers. So we'll want to take the middle one just like before. So we should just be able to do math.floor update. So we should just be able to do a math.floor change, cur.length divided by 2. Okay, seems promising. This is not change, this is cur. Sorry, I keep making that typo. And then we need to define what the correct change function looks like. So let's do that. So we have a function that we're going to define right here called correct change. Okay, so yeah, this is going to take a while loop. We'll do this while it's not correct. So while not is change correct, and we want our ordering rules, and then we want the current. Yep. So we want to go through our rules. So we'll do ordering rules dot for each. We'll get the left and the right rule. Let me move my keyboard closer. Be considerate. Okay, so we get our left and our right rule, and then let's get the index of those. So we have the IA is equal to cur dot index of A, index of B, cur index B. If IA is greater than -1, and IB is greater than -1. Okay, so if that's true, then we found both of those. Let's go ahead and start there. So if we found both of those, what do we need to do? I guess we need to check and make sure that if IA is greater than IB, then we need to update them, right? Okay, let's swap them. So then I think we can swap in place in TypeScript or JavaScript. So if we do cur IA cur IB is equal to cur IB cur IA. I think that should swap in place, which means that eventually this should end, right? Because the change will eventually be correct, even if we have to go through it a couple times. But we need to return after this while loop is finished. I think we would just return cur. I hate this name, so we're gonna rename this really quick so it's a little more obvious. Just call it change. Okay, what is our complaint down here? The plus operator cannot be applied to types number, array, and number. Oh, we're missing our default type for the accumulator. Yep, okay, that makes sense because, so here, you can see here that the accumulator here is a number array because we're reducing changes, which is an array of numbers. But if we give it a default value here, the accumulator will start at that default value, which is a number, which will fix our issue in this case. Let's give this a run. 5, 7, 2, 3. I don't know if that is a good value or a bad value. Hey, it looks like it's correct. Okay, so that we still got a long way to go to catch up, but that wraps up day 5 of Advent of Code.